and welcome everyone to the very first session of Bucerius Legal Tech Essentials 2020, live from our studio at Bucerius Law School in Hamburg, Germany. My name is Dirk Hartung, and I'm going to be your host tonight, or today if you're joining us from further west. On location today is Professor Dan Katz, who is in fact at his home in Chicago, Illinois. He will be kicking us off with an introduction on artificial intelligence and law, a primer. But before we get to that, I want to quickly explain how questions work. Now, we hope you have tons of questions, but to make sure that I can actually see them, please use the Q&A function at the bottom of your Zoom screen. I will go through while Dan is giving his presentation. I'll group them up, and then I will, once he has finished, go through the most urgent ones with him. We hope to cover as many questions as possible, but we know that maybe one or two questions will remain unanswered. For that purpose, make sure that you know that the conversation actually continues at Twitter at #BuceriusLegalTech. And just before we start, let me say thank you again to our friends from Baker McKenzie, whose generous contribution makes all of this possible. Now, without further ado, Dan, take it away.
All right. Well, thank you so much, Dirk. It's my great pleasure to be here with you today. I wanted to remind everyone that there was a pre-session that was held on last Thursday, and it is available online in your email for those of you who may have missed it but would like to watch it now if they want to catch up or backfill a little bit. So today, as Dirk noted, I'm going to offer a primer in AI and law with a focus on analytics. Now, this is the no math and no programming version of these topics. In our on-campus program in the summer, we offer the 12-week version of these topics, which is obviously much more substantial. And I actually personally offer a 2-semester version of that at my home institution. So of course, this will just be the primer, but with that said, on with the show. So AI and law primer, an introduction to artificial intelligence and law. So AI and law, an introduction. Well, I think the kind of impulse for this is if you look at the vast majority of products that we've seen come on the market in the past decade, the vast majority of them purport to use some class of artificial intelligence. Not all of them do, but many of them do. So in this sense, we thought it made sense to explore AI right off the bat, and I'm going to do that today by looking in general and then with law specifically, because if you look at a lot of the applications, a lot of the concepts have been developed from outside of law and then have been sort of brought inside of this domain of application. Then we're going to get in and talk about specific examples within AI and law. And some use cases. There are many other use cases which we will not have time to cover today, but which are, in my view, reasonable extrapolations from at least from a level of abstraction from the problems that we're going to highlight today. So AI and law, or AI is all around us. If you've been paying attention at all, the past decades, last couple of decades, and particularly the last decade, has seen some pretty impressive displays. You go back 2 decades, you'd see the IBM Kasparov Deep Blue tournament. More recently, the Jeopardy versus IBM Watson tournament, which is a quiz show where you have to answer in the form of a question. And then more recently, the AlphaGo tournament with the great Go masters, where machines are playing, these various games against experts in their field. But more kind of close to home, there's also these sort of displays. So something like teaching a machine to play poker, which involves both calculating probabilities, but also doing things that are more human, like bluffing. And then something like being able to process large amounts of information to look for crop disease, which is, again, historically a more human-centered task. A lot of focus on image recognition. We've seen this in the context of looking for diabetic retinopathy in individuals, and looking at various cancer cells and looking for cancer cells under microscopes, but teaching machines to do that exercise. Then more generally, we've seen examples like teaching machines to write relatively formulaic stories that are written for sports events where, this person does that thing and that person does that thing. And these are, a little closer, a little more formulaic, and we're getting a little closer to kind of the world of law. But, again, these are more like paint by numbers sort of examples. Things like this, maybe a little more hyperbolic, but machines building other machines. But then there's sort of things like this, which are always interesting to me. When, teaching a machine the conventions of beauty. People think there's this kind of art column and there's this science column, and the two can't mix. And it's a little bit more of a complicated account than that, which is, what makes something beautiful does follow conventions, and styles do follow conventions, and which is to say their underlying rules or principles. And those are the types of things that machines can identify with some training. And so I'll send you here to this for many other examples of some of the impressive displays. This hardly scratches the surface of what has been done over the past few years. Now, if you look, practically every company on the planet is racing to embed some class of artificial intelligence into their products and services. And then for those of us here in law, I think there's at least two reasons why an individual lawyer, law firm, or legal department should be interested in recent developments in artificial intelligence. First of all, number one, this is what the world is becoming. And for those of you who work as lawyers in companies or represent organizations, this is what the client's world is becoming. And so these topics are getting intertwined with traditional or classic legal questions. So having some more than just a passing understanding on the technical end of what's going on with these systems, I think would allow you to be a more effective lawyer, whether it's an advocate or on the transactional or planning side of things, but either way. And then kind of much like the business world, the delivery of legal services is beginning to be impacted by AI. I think in the 2010s, there was a lot of kicking of the tires on these principles, a lot less adoption pound for pound. 2020s, I think organizations things will go deeper and deeper into organizations over time. So I think in light of that, the question is, how do I deliver value and how do I leverage these tools as a lawyer or a professional working in a legal department or law firm or other allied organization? So let's go back and just give you a little bit of the history of this field, if I might. And again, for each of these things I'm mentioning, you could spend quite a bit more time looking through and learning more about. But I just want to remind everyone at the outset, just right off the bat, because I think this is kind of one of the classic kind of traps or mistakes that people get sucked into, is before there were computers, people computed things. People did all the computing. And in fact, if you go back to the beginning of the 20th century, you would see there were when people talked about, quote, computers, they were talking about people whose job it was to compute things all day. Like you would go into and there'd be a whole sea of people and they'd be calculating things. And in teams, in groups, they'd be essentially doing parallel processing of computational tasks only with people. And so if you want to sort of think about the computer age as about going from every computation being done by people, and that's a very expensive proposition, to more and more computation being done by machines over time. Humans did all the computing originally. And so again, how much of that can be done by machines? That's the open question. Now, if you kind of take the media version of the story, the robot lawyers are here or something like this. It's a more complicated kind of account in reality than that. But, that's kind of the first pass we had on a lot of these topics in the 2010s. If you reflect upon your own decision-making, there's a strong linkage between, work that's been done in behavioral psychology to think about how humans make decisions and thinking about how we might program some of those into machines. So I want you to reflect on the nature of your own decision-making and think about what you're actually doing when you confront a task. Here's three kind of streams of work streams or kind of processing streams that you sort of use to work on problems. These are not the only three, but these are three that are relevant to our conversation here today. The first thing is you look for patterns in information. A second kind of thing you do is you weigh various variables and then take a decision in light of the way you weigh those factors or variables. And then another thing that lawyers do a lot of, and individuals more broadly, is making conceptual leaps between problems, typically using analogical reasoning. And so let me give you examples of each of these in the general sense before we get in more detailed sense. So here's an abstraction of a weighing of decision-making process where you're weighing various factors. You might have, multiple factors. You could say, am I going to win this lawsuit? Just to kind of jump right into the law example. Well, there's a lot of factors about this lawsuit. And the question is, how do you weigh all those factors and then process that with a person here or machine here? I'm pointing the computer in front of me to output a decision. And just remember, you can also blend these streams of intelligence, but it is, I've got these factors, I'm processing those factors, I'm outputting. So I have the function in there, that's the math way, that's the computer's way, and then there's the alternative, which is this processor here. So that's an abstraction of what you're going to do in your mind, and you're going to do this weighing on all types of topics before you go to bed tonight, many, many times, in little ways and in big ways. Here's a second thing we do. We match patterns. If you think about evolutionary biology, it's an algorithm which privileges very good pattern matching. Like, that is a predator, and I need to keep my distance from that predator. And I need to detect predators. I need to match patterns. What doesn't belong here? And is that a poisonous berry? Yeah, and if you get it wrong, it's a very steep learning curve in biology. Now, I've always liked this example. If you look at this pie chart here, and I want you to just take a second in each of the pie charts and tell me what's the largest slice. And you're going to have to really stare at it for a while. And just take a second and look at A, B, and C, and just tell me what you think the largest slice is. And it's like, is it black? Is it blue? Is it green? Is it yellow? Is it red? Now let me show it to you as a length. Easy. We're very good at interpreting distances because this cognitive apparatus has been wired to do that from evolutionary biology. We're not good at interpreting the distance in those pies. So that's one of the reasons you shouldn't use pie charts and visualizations. But more specifically, I just want to show you that you're wired to do certain types of decision making because this machine has been hooked up in a particular sort of way, processed by your visual cortex, and out you go. Now, if you think about analogical reasoning, that's a really hard task for machines. So, I get to see a lot of the legal tech companies. Folks kind of come to me when they have an idea or even when they have a company that they're trying to get started or what have you. And, when people start talking to me about analogical reasoning machines, I say, whoa. That's like you're picking the hardest problem in all of law to work on. Why don't you work on problems that don't involve this stream? This is something machines are not great at and humans are pretty darn good at, especially trained lawyers are pretty darn good at this task. Reasoning by analogy. So it's a bad candidate to apply artificial intelligence and a good candidate to apply it people. So let's start and actually say, what is this term, artificial intelligence? Well, can somebody offer a working definition? Can you think of a working definition? Well, here's one. AI is the study of how to make computers act like the ones in the movies. Okay. Here's a more official definition you can take a look at. It's the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to the task of using computers to understand human intelligence, but it does not have to combine itself to what's been biologically observable. And I just want to point out, we're often inspired by biology. So, for example, there's a well-known algorithm called a neural network, and that is inspired by your neural pathways and your neural architecture inside your mind. We are not confined to what we've seen biologically, but the field has always been inspired to some extent by biology. So people often look to what happens, what is our best understanding of how this machine works? Maybe that's a good starting place. But again, we're not limited to that as the set of places to go. But let me just say, though, lest anybody get lost in all this, the big idea is how do we develop in machines some sort of synthetic representation or artificial representation in a traditionally human-centered decision-making process, processing process, cognitive process, computational process. There's a lot of different terms people use. Now, this field has a long history, just to point out. Here's two of the leading lights. You can read more about them. John von Neumann, has a claim to be one of the top minds of the 20th century, did a lot of things, was the founder of the field of game theory, developed the architecture of the computer, was involved on the Manhattan Project, what have you. Alan Turing, a leading light in multiple fields. There was a famous movie fairly recently about his time during World War II, and particularly focused on his time trying to crack the Enigma machine during World War II. But he made major contributions to a number of fields. Also very popular now because of his contributions to cryptography, which is very popular kind of in the field of crypto, Bitcoin, and Ethereum land. Now, here's a kind of big important thing to understand. Before 1949, computers did not have what you might call one key prerequisite for intelligence. They could store commands, but they couldn't execute commands. So you can't really have intelligence if you can't store what you've done. You can't learn. So that's a very important dividing line kind of in the field. The other thing that also needs to be noted, because there have been hype cycles and there have been false starts and AI winners throughout the history of this field. Just to give you an example, even some of the world's leading experts otherwise have gotten things pretty wrong. So here's a quote: "Machines will be capable within 20 years of doing any work that a man can do." Herbert Simon, 1965. Now, in the 20 years that followed, that did not come true. However, this gentleman, a very famous economist, behavioral psychologist, kind of one of the leading founders of behavioral economics, picked up the Nobel Prize in economics, but did not get that statement right above. Now, it turns out, if you look, a lot of the ideas that we're leveraging today were actually developed decades ago. So I was like this. This is when the first academic paper on each of these methods was written. 1958, 1960, 1967, 1986, 1995, although random forest, I'd really say it's 2001. But, you know, that's sort of a debate on the margins. But the point is, this is when these methods were developed. So I want you to understand, does this method exist, and can we theoretically do it? And does it actually work in a commercial context? So there have been hype cycles of sorts. There's been the peak of inflated expectations. That's, where Gartner puts ML. Here's advice. Don't start a company when something's at the top. That's fine. You can do it on either side of the bottom as long as you can make it. But it's the word you get kind of an outsized valuation. You can't kind of survive or you fall under the weight of it. But, I do think this time will be different, at least in the medium term. But I do acknowledge that anybody talking about this has to bear the weight of the fact that times in the past people have overstated the case and then had to walk things back in terms of what was possible with artificial intelligence. What I want to flag for you is, even though those methods were developed many years ago, there are other pieces of the equation that have to be sorted out. So what's powering this AI revolution? Massive increases in computing power, and corollary, the important kind of amendment to that is also the cost of data storage decreasing rapidly. So many people are familiar with this one, Moore's Law. We've been doubling the speed of a processor every, let's say, 18 to 36 months for the past 50 or 60 years. And you keep doubling and doubling and doubling numbers, things sort of grow. That's an exponential growth, but it really sort of begins to defy your expectations, because we're used to, in many examples, linearizing distances between objects, which is a great heuristic across all problems that you ever face. It's a good rule of thumb. Lots of things behave linearly. Some things don't. Some things don't. Some things are exponential, like some of these epidemiological models about spread of a pathogen like COVID-19. They exponentiate. That's the reason it looks. The challenge is, when you're at point B looking backwards, the linear and exponential function, they look the same, and then all of a sudden it just accelerates, and it sort of gets away from you really quickly. So in this context that we're talking about here, things grow faster than you expect because of the exponential growth. Now, the other half, and equally important part of the story, is the cost of data has exponentially decayed. So one's going up exponentially, one's going down exponentially. Just to show it to you, here's the price of 1 gig of data storage. 1981, that would be $300,000. You go to like a trade show or something, and they'll just give you a thumb drive today, because that same gig is 10 cents or less. It's actually less than 10 cents now. That's 2011. But the point is, it's pennies per gig now for data storage. Would have been a lot of money in the past. So a lot of those methods that I identified require reasonable amounts of processor speed and the ability to store reasonable amounts of data, which was a very expensive proposition not all that long ago, and now is a relatively cheap proposition. And so in a sense, we're like data hoarders now. We just can't get enough data. We just hoard it and hoard it and hoard it. We don't structure it typically, but we just hoard it and hope to save it for the future, I guess. So most of what people are doing in AI today, if you look at the top companies in the field, are trying to predict things using algorithms. Data, which is just an algorithm, is just a recipe for a machine to interrogate data. Recipe for machine to interrogate data. So I want to say a few key ideas about prediction so that you've heard these before. Two big things. First, I want to mention what an inverse problem is, and I want to highlight system dynamics. This is going to connect to some other ideas that we're going to cover throughout. One, if you look at mainstream science, historically, it's all about testing hypotheses. That's the mainstream of science. So what is that? I have a hypothesis, I go get some data, and I try to falsify that hypothesis with data. And that's kind of down the middle, normal science. That's the kind of paradigm. That's a deductive paradigm. That's just, if you know your philosophy of science, that's the kind of Popperian school of Popperian falsification. And that's kind of the way we build knowledge, is through hypothesis falsification. That's kind of one tradition. The alternative tradition, and I point you to a paper by a guy named Leo Breiman, who, there is no Nobel Prize in computer science, but if there were, he most certainly would have gotten it. Included one of the things he developed was random forest, the random forest algorithm. But he has a paper called The Two Cultures of Statistical Modeling, the Two Cultures. Culture one is deduction. Culture two, induction, partial or complete induction. That's the alternative. That is called a lot of different things, but it's called a non-well posed problem or an inverse problem. And this is where you work backwards from the data to the model, not the other way around. Now, you might say, okay, what is he talking about? I just want to show you, these problems were not solved through the hypothesis testing framework. People didn't really work on them this way. They used it using induction, large amounts of data and algorithms to try to interrogate and extract information or extract signal. You remember the spell checkers back in the 80s and 90s? They were terrible, terrible. They did not perform well. They always got it wrong. It turns out that billions of people clicking around is a much better way to orchestrate a spell checker, or connecting. This is where Amazon really became a global juggernaut. People who bought this also bought that. That's collaborative filter is the term for that. But the basic idea is that they connected all the books and the matrix of co-purchases, and they're interrogating that in order to try to serve up to Dan or to Dirk what, hey, you actually probably will want this in light of what you've wanted. And same thing with Pandora and many others of these problems on the board. That was based on the Music Genome Project. So the model there is you induce a plausible model from data, and then you have to validate the model on the back end, including putting it in front of people and creating some sort of a feedback loop where people go thumbs up, thumbs down, and that trains the model in the background. The validation step is still required. You need to validate these models. So you can do that either out of sample or with forward prediction, or both. Out of sample means you test it on data it hasn't observed and then see how well it will work. Forward prediction is deploy it in the market. So let's say you were trading stocks, hypothetically. What you'd want to first prove to yourself is, had I been using this model, would I have done well or done poorly? Then forward prediction is deployed in the market. And then really ideally you want to be doing both. Second thing to keep in mind about prediction is system dynamics. Imagine two different complex systems. One is weather and the other one is tides. Now both systems, and we're going to talk about complex systems later on, both systems are complex, but one is easy and predictable. Tides are very predictable. We have, minus a hurricane or whatever, high tide's going to be at this time, set your watch. Weather is very chaotic and difficult to predict. In fact, outside of 14 days, basically predictions converge on the almanac, which is a form of prediction, by the way, but it's about aggregating data over time. That's really what an almanac is. It's early data aggregation and prediction. But nobody says, hey, I have an almanac, set your watch, it's going to rain at 4:30 today. It's not that type of prediction. In law, we have a lot of weather problems. Some tides problems, but a lot. So what does that mean? That means when we talk about AI and prediction, you need to have a baseline model to compare against, and it isn't perfection. And most of the time we benchmark experts, they aren't doing perfect either. So the question isn't, is it perfect? It's how is it better than the existing method today? And I have a lot of people in this field have had difficulty getting their head around that in reality. Part of it is because they romanticize human decision-making in ways that the evidence doesn't really support. And again, there's a formal treatment of this from various domains. How hard is it to predict a system? Okay, so the big divide in AI, transitioning out of that, those are two big background ideas I want you to know about. The big divide in AI is between rules and data. Now, this field AI is a broad field. We're only scratching the surface here today and even in the session to follow. But I want you to see there's a lot going on. There's a lot of different that you can combine some of these methods for certain problems. But the big divide is between methods that are data-driven and methods that are rules-based. And there are ways to combine them, but these are kind of the two camps that have existed historically. Now, I will say rules-based AI was very popular, particularly in the 1980s and 1990s. And part of that had to do with the data-driven methods were very hard to execute because the computation required and the data required, it was too expensive for most problems, where rules-based methods were much more popular then. And, you know, that's turned around a little bit because, again, data is very available and processors are cheap, relatively speaking. But keep this in mind, this division over the two sessions we're going to have. Today's the data-driven day. So that's going to take you into machine learning and natural language processing. So expert systems is something you're going to cover more in the next session, but I will just note, you know, that Richard Susskind has permanent technical credibility in this field because he developed the first expert system in law back in the middle of the 1980s. And I'm going to jump past this because you're going to cover this tomorrow. But the big idea there is to encode the rules of a decision-making process by asking the expert what those steps are and then turning that into software by as a consequence of kind of interrogating that expert. Again, you can watch the first 14 minutes of this video if you want to hear about the origins of this field from Richard himself. We'll be in this session later to talk about online courts. But now focusing on data-driven AI. The alternative to hard coding is to let the data do the lifting. So again, when you come to here, first we saw this, now we see that a lot, at least in general AI, this is the case. Again, if you think about a driverless car, it's actually a combination of rules and data. The machine's got sensors all over the place and it's trying to process and make a prediction about, do I slam on the brakes? Do I move into the other lane? Do I accelerate? You know, what action do I take in light of what my visual cortex, in this case represented by the sensors, is doing? So we want to be able to teach a machine to predict what to do. Not perfect prediction, but very high fidelity prediction, because we don't want to have an accident. But I want you to come back and think about this over the two sessions. This particular problem is full of rules and data, People are following rules, but there's also data, and it's actually a combination of both. But the question is, by what method do we learn the rules? Do I learn the rules by asking an expert all the rules of driving, or do I watch a lot of people drive the car? And it turns out that watch a lot of people drive the car is a much more fruitful way of learning the rules of driving and making predictions about the steps of driving they will take. So again, the alternative to hard coding the rules is to let data do the lifting. And that's going to take you into these two fields, which are subfields within AI, machine learning and natural language processing. So let's start with ML. The goal in machine learning is to predict some class of outcomes, legal or otherwise. I want to predict something with an algorithm. Here's just a few of the use cases within law. Predict relevant documents, that's e-discovery and due diligence. Predict contract terms and link that to outcomes. You might call that data-driven transactional work. Predicting rogue behavior, that's kind of data-driven compliance. Predicting case outcomes and costs, you could call that, if you're outside this field, data-driven legal underwriting. And this is sometimes called reg tech in certain areas, but predicting regulatory outcomes. That's what lobbyists do. They try to develop strategies to influence regulators to do certain things over other things. Lawyer lobbyists do that. So commercial examples, there are many, many. I talked about this in the pre-session. You know, we have 1,000 to 2,000 legal tech companies globally. There are many, many companies. So these are just a narrow sense of the products. So here's contract analytics, a couple of examples. Judicial analytics, a few examples. E-discovery or e-disclosure, they call it in the United Kingdom. Predicting which essentially, usually it's emails, it doesn't have to be, which documents are relevant to this particular case. Spend analytics, this is one example of many of spend analytics that's out there. Negotiation, you can think of that as people think of that as an art, but that it can be informed by science. And here's an example of predicting that was in the FT I commented on, but this is, arbitration, trying to predict the outcomes in arbitration disputes, decisions of arbiters. There have also been a number of academic papers that are out there that I'll point you to. This is a paper that was in PLOS One for medical malpractice. This is a paper and now there's a company around this called Blue Jay Legal, predicting outcomes in tax law, securities fraud class actions. There are several papers. This was the first of several predicting the European Court of Human Rights using different types of methods. This is a company, but based on initially some work done on Stanford IP Clearinghouse, Lex Machina, which is now part of Lexis. And here's a couple of transactional examples. And here's our paper on predicting U.S. Supreme Court decisions. This is not meant to be an exhaustive list. These are just concrete examples that I can send you to take a look at. Now, this is sometimes called predictive analytics, or because we love to put the word law in front of everything, or legal in front of everything, so we call it legal analytics. I just want to remind you, as I've already said, this is not about perfection, but about comparative predictive performance. What does that mean? That means how well do people do on the problem today, and can you do better using these methods? In some instances, it won't be worth it. So you just use the existing process. Some places it will be worth it. Then you can maybe consider these approaches. So you got to kind of look at the economics to see whether it's worth it. It very well may not be on particular problems. Now, in machine learning, there are two major forms of machine learning: unsupervised and supervised machine learning. Clustering is a canonical example of unsupervised machine learning. So let me give you, clustering is about putting similar objects together. And I put the word similar together because that's the colloquial way of talking about it. But what we need to convert is this colloquial notion of similarity into a mathematical notion of similarity. And I mentioned earlier, when you say these two things are similar to one another, you're actually taking all the factors. If you say, well, these two people are similar to one another. Well, in truth, they're different people, right? Everybody's a special snowflake, as they like to say. Okay, that's true, but some snowflakes are maybe more like other snowflakes. So in other words, there are factors that make you similar to other people, but you're still a unique person. So when you're doing the grouping of people into groups, then you have to say, then you're picking certain dimensions to do that grouping. So again, it's a multidimensional concept, similarity. And people love this one. It's always a good one. The blueberry muffin Chihuahua example. Now you look at that, and there's a lot of similarity there. So to distinguish between which one's the the Chihuahua and which one's the muffin, you have to really kind of look at it carefully. So you're actually, in your mind, you're discriminating like the factors that tell the difference. I mean, like, maybe the nose, but even some of the blueberries break open and they look like the nose of the Chihuahua. But anyway, you can tell the difference, but you have to really focus on it. So when you think about similarity, you should think of these two extremes. Everything in one group, which is kind of not a useful idea. I mean, again, if you're actually trying to put things into categories or groups, if everything's in one group, that doesn't really help you very much. Everything's in its own group. That's if everything's 100% similarity threshold. Usually what we want is something in between, but it's not always clear where to stop in that spectrum. So you have to kind of look problem by problem. Deduplication, which is done sometimes in e-discovery to get rid of stuff, is playing around with the 100% similarity threshold. But again, in math, you got to come up with a distance function or similarity function, mathematically a distance function, in order to put people in a similarity index relative to one another. Now, this is what it sounds like in real life if you're in a law firm or corporate legal department. What were the last 10 deals, quote, like this deal, where like means mathematically similar? What were the last 10 lawsuits like this lawsuit? So you use these clustering approaches sometimes to group relevant or close enough cases so that you can build a data set to actually analyze. So you can use some methods and combine them with others. Clustering is useful in organizing and locating documents, for example. The classic example is you're given a body of unorganized documents and you want to put them in groups. So you might want to roughly group them before exploring them. So here's a bunch of bilateral loans, which I threw into a system that we developed. And I'm looking for the ones that are LIBOR implicated in this case. And one well-known algorithm is k-means, which we won't talk about today, but it's a very well-known algorithm that's been around a long time. That's just grouping documents. And if you look at e-discovery and due diligence AI modules, they typically leverage supervised machine learning. Here's a visual example of how those work. So now we switch from unsupervised to supervised. How do we do that? Well, imagine this. Every pixel on that screen over there is an individual document. Hypothetically, there could be millions of these in theory. The task is to predict with a machine which ones are relevant. Now, people on the outside always think, how would you ever be able to predict relevancy? How would you ever be able to predict relevancy? That would seem to be a very difficult concept to teach a machine. Well, the way we teach it is by essentially sitting over your shoulder and watching somebody do it, and then trying to predict or infer what makes something relevant versus not relevant. That's what the machine is being taught how to do. So what you might do is, what you would typically do is start with a random sample of those documents. And then you take humans and you say, go code these documents. And that coding exercise is supervised learning because the humans are the ones providing the supervision. The machines are being supervised by humans. And in the simple binary case, you might just say, I want you to take these documents, team, and I want you to label the ones yellow that are relevant and leave the other ones white. And then I'll have a separation. I'll have the yellow ones on the one side and the white ones on the other. And then what I want them to understand and have a machine try to learn using some sort of classification method is using this gold standard data that I have is, what is it that separates the yellow documents from the white documents? What is it that allowed a person to do this? Person says, well, this is relevant, this one's not. Why? What is it about that? And can I learn that? Teach a machine to learn that and predict that. So in law, this thing's been called predictive coding. Now, if you go into computer science, they've never heard of this predictive coding topic. That's more of a marketing term from law, but it's binary classification of documents. But here's the key idea. When you put it in the yellow group versus the white group, there's some factor or feature that caused you to do that. And if the machine can learn what it is that's present in the one side versus the other, then when it gets a new document, it can send it this way or that way based on these features of the documents. That's what people are doing. Relevant, not relevant. Privileged, not privileged. These are some of the factors. The text, the author, the date, other types of metadata, other types of information about the document that's contained therein. Now, if you get turned around in this context, just think about spam filters. Your spam filter is an example of this technology already. The machine's trying to prevent spam messages from going through because people, there's phishing scams and other types of, bad behavior people are trying to engage in out there to potentially have an InfoSec problem. So there's this constant little low-grade war between the spammers and the IT professionals that are trying to, keep those messages from coming through. So when we apply machine learning to this problem, the learning problem is, what is it that distinguishes, again, the yellow from the white documents? These algorithms are going to try to recover or learn what separates the two classes. Once you've learned the rule or the boundary, then you can apply it to a much larger set of documents. So you supervise it and train it on a small set of the documents and try to apply it to a much larger set of documents. So what we want to do is take what we've learned here and apply it to the rest of the documents. Remember what the alternative is. A person reads every one and reviews every one of these documents. That's a very laborious and expensive task. The key thing you need, though, is some validation. I mean, you need to prove to yourself and to others, often to a court or what have you, that the methods we're applying actually work. And so what you often will do is have another sample, and then you're going to show, hey, the machine can predict as well or better than people, so let's use the machine because it's a lot more cost effective. And there's a bunch of statistics people keep on this. But that's the key idea here. You need some level of validation so you can feel comfortable going forward. And then once you're comfortable, you can apply it here. Now, I just walked you through how it works. Now, I didn't talk about any of the algorithms or the math, but that's how supervised learning works when you want to predict, in this case, whether a document is relevant or not. So both in e-discovery and due diligence, we want to teach a machine to classify a document or components thereof. In diligence, we might want to find a clause in a contract, assignment clause or a change of control clause or something like that. But we're going to learn from old documents to predict new documents. That's the big idea. So speaking of document properties, I've glossed over one of the most important aspects when it comes to law that's critical to the success of data-driven AI. And it's where I'm going to close our session in the last 10 minutes and then open up for about 10 minutes of questions here, which is the second half of AI, if you want to, or data-driven AI, if you want to think of it. People always argue where it should fit in all this, but I'm not going to get into that today. But natural language processing. Now, I want to make sure you have this idea, because think of it as one of the things you're going to have to confront in law. And I want you to at least leave today with a rough definition of NLP. The rough idea is it's the statistical representation of language, the rough idea. If you think about language as the root of consciousness and thought and culture and shared meaning, and here in law, La La Land, it is the coin of the realm. It is what we do. In fact, my law students, they consider, I've heard this many times, the foray into this field as an exercise in, quote, learning a new language. I hear this every year. You hear people say this. For one L students in particular say, it's like a whole different set of, this would be true, by the way, if you went to medical school. They use a lot of medical terminology, and it sounds like jargon if you're outside the field, but if you're inside the field, it's just an efficient way to communicate. If you think about it, in support of this task, to train this machine to process all that information, we have specialized dictionaries, and we have text-based summaries, and we have all these other resources that are designed to support this linguistic immersion program, which is basically what legal education is. It's not the only thing it is, but it's a major factor, is an immersion into a new language. But it's not just the consumption of language, it's also the production of language. It's a field where we do a lot of linguistic construction and interpretation. If you think about it, lawyers and judges and regulators, many others that are in law, are massive producers of text, briefs, memos, statutes, opinions, regulations, contracts, all these sorts of things, and many others. These are legal work product. And they're part of the data that you got to be able to process if you're going to use it in many of these problems. All these systems are producing tons of this every single day. Now, even many years ago, the scale and complexity of the volume of information in law drove labor market specialization. And we have had information technology in this field for a very long time, because the scale of law, even more than 100 years ago, was very voluminous. And so we had longstanding indexing systems and summaries and tracking systems. And all of these were efforts to get a handle on the complexity of law. But the complexity of law continues to grow. And will be a theme we explore throughout this, but just as an example here. So NLP, again, together with allied methods, in my view, can help in a variety of different ways. When we have all this text that's now readily available, digitized text, both within law and outside of law, all these examples, large bodies of text. And there are patterns in this legal language that are useful to detect. And again, the question is, do I teach a machine to detect the pattern or a person to detect the pattern? But people are trying to pattern detect in these words, in these languages. There's all these patterns in law. That's an oral argument at the Supreme Court. My former student, Patrick Ellis, created that when he was in my 2-semester class. Always liked this example. It's not all the information. It just gives you an abstraction of what happened in the oral argument back and forth between the judges and the lawyers. The key question is, how do you take these general advances in NLP and take them into law? We have a domain-specific language here. So a quick history. In the 60s, we saw the first efforts to do computer-aided legal research, which later became the Lexis terminal. And then West built a competitive product where they took the books and began to project them into machines. Uptake was slow because the cost was very high because of Moore's Law and Kreider's Law. This was an expensive proposition. If you look at that talk that I highlighted earlier from Richard, in the early 1980s when he came on the field, there were fewer than 40 papers in AI in law, let alone NLP in law. So if you look at that talk. The first AI in law conference or Jurix conference started, there were still relatively few papers. And the field got very focused on legal argumentation and legal reasoning. And I think, if you've ever spent time around computers and around the way lawyers kind of reasoning, it's a very attractive kind of combination. I will say it's like the hardest problem in all of law. I told you, analogical reasoning machines, it's an incredible problem if you can really crack it with machines, but it's a very hard problem. We have a lot of other problems in law which are not nearly as difficult to work on. And so, at least for those of you who are kind of more on the commercial side of this, I would encourage you to stay kind of a little away from these types of legal reasoning, legal argument problems, because they are very hard to crack, and you're more likely than not going to fail to do it in the timeline you have. And even legal theory, by the way, and NLP share a relationship. This is a long debate in legal theory between realism and formalism. This is like formalism all the way. The old idea of Hofeld's legal relationships, that the law was essentially a logic computer, which I don't personally subscribe to, although aspects of it kind of look more like, some parts of law look more or less like this, okay? The other big divide in NLP is between syntax-based methods and semantic-based NLP methods. So syntax is looking at words, the frequency of words, parts of speech, things like that. Here's some examples. The easiest version of a syntax-based method is Control F, find. That's exactly matching a string. Then you can have a fancier thing like a regular expression, which are actually rules that are used to look for patterns and information and to return results. Here's an example of a regular expression that's looking for a statutory citation below. You'll have access to these so you can go back through. A little bit fancier thing is to look at the frequency of words within a document and then use that to predict what the document is or is like. And a classic thing is to take the term frequency within the document and look at the inverse of that relative to the document frequency across all documents in a group of documents. So in order to put things in groups, you may rely on unique patterns in terms of the frequency of words. Again, this is a simple method or simple algorithm that actually works pretty well on a lot of problems. But it's all syntax-based. Semantics is what we spend a lot of time with human lawyers on, which is the deep meaning of words. You think about legal writing, or people spend a lot of time in statutory interpretation. Painstaking processes where you look at the deep relationship between words. Most of what we do with machines does not involve semantics at all. It involves syntax. Semantics is what do these words mean? What do they mean in context? How do they relate to one another? How do they create higher order meaning? Hard problem. These are some of the places where we have deep semantic interpretation going on. Teaching a machine that is hard. Teaching a person that, by the way, is hard. We spend 3 years with law students trying to teach them this. Many years with law students and even practicing. People spend a lot of time really getting good at this. So it's not an easy problem for people, and so ergo it's not a trivial problem for a machine. Semantic is hard for machines. So I want to focus at most of the NLP infused tools today basically largely or completely ignore semantics, other than one kind of example, word embeddings, which I might get to time permitting. But I would currently frame the state of affairs as, how well can we perform with these machines without having a deep semantic understanding of legal language? How well? It turns out better than you might think, which is a very odd thing, because we spend so much time with people teaching them the deep semantic meaning of words. So the key is, when you pick a problem to work on, it has to, and you're going to use a syntax-based method, it has to be able to kind of meet the properties of being able to be successful. If you need to know the deep semantic meaning of a word, use a person, don't use a machine. Circa 2020 and for the foreseeable future. So again, what is the rough definition of NLP? It's the statistical representation of language. So I'm going to jump to a few examples to close us out of use cases, and then I'm going to open it up. So here's just a few use cases. There'll be more information available in slides, but one classic one is technology assisted review, which I already talked about. This is a famous paper in this area where this is e-discovery, where NLP is a big part of the story, building a classifier to process the text, but also to predict the outcome of or in this case, whether the document's relevant. So this is information on that. There's been work done on legislative and regulatory prediction. So this is a good paper by John Ney trying to predict whether a bill would pass, in this case, the U.S. Congress, by looking at the words in the legislation. We did some work looking at regulations. Here, we're trying to map all the regulations in public filings and securities filings. So this is an example. If you look at a 10K, we're looking at all these different acts and extracting those, and then trying to look at the patterns contained there. And I'll send you the paper to look at it. But ultimately, that's the type of things people want to use, and sometimes they want to use them to predict whether the stock is going to go up or down, by the way, but other things about the company. Contract analytics is a place where there's been a lot of effort to try to wrap NLP around and prediction together. And so just want to flag the division in contracts. If you take contracts, you can say everything that happens up to the execution of a contract and everything that happens thereafter. So cycle times, negotiation optimization, trying to either move the deal along better or to get a better set of terms in the contract. That's everything that happens up to execution. Then there's all this batch analysis exercises that are done after the fact. Classic examples are due diligence when somebody's going to buy or sell a company, or rev rec. Other kind of more geopolitical examples are GDPR, LIBOR, Brexit, which are forcing people to look at contracts in batch that have already been executed. And here's a couple of papers, by the way, about academic papers about pre-execution strategy, although there are these contract lifecycle management companies, there are various of them, are trying to work on that entire spectrum of all the way before it's even executed, all the way through to post-execution and obligations management. Briefs, people would use machines to try to identify patterns in briefs. And here's a commercial example in case text. What am I missing? What should be here that isn't here? And the last thing I'll point to you is prediction, and I want you to see, I said NLP's over here and machine learning is over there, but you can combine them. For example, you can use factors about writings that have been done in the past or the briefs themselves in a case and use that to predict the outcome. So here's the examples here. They're trying to predict. It's a little bit of, they did it a little bit of a different way, but the different papers of this spirit are trying to predict the outcome using this case, pieces of text. We took a representation of the text in terms of topics and used that to predict. But a lot of these papers out there from across the world are using mixtures of prediction algorithms combined with signals or little pieces of information from the text created where they make variables out of that and then use that to predict. So I'll get a few more examples here. And again, you'll have the slides, but there's examples from all over the world from doing this. So with that, I think I'll pause and I'll open up. We'll do 5 or 10 minutes of questions. If people have to drop off, that's fine. And if not, and we'll again, the conversation continues on Twitter. So that I raced through a bunch of different stuff. Again, we do a 12-hour version and I do a 2-semester version. So I barely scratched the surface, but I want to show you there's a lot here actually. Over to you, Dirk, for some questions. Dirk's been aggregating them.
Yes, back to me.
Okay. I caught him short.
There you go.
He was checking his email, damn it.
I was checking the questions because we've had
of course.
We've had quite a few. Which is what happens if you invite these many people to ask questions. But I think I kind of grouped them up together, and I will go through them not necessarily in the order in which they came in here, but what most people were wondering about. So one question that has arisen multiple times is, if these things are NLP based, how important is English as a language? And if I have solutions that say work in one country, can I take those solutions and move them to a different country, different jurisdiction? How does that work? And is there really, apart from the English speaking world, any meaningful application of natural language processing in law? Is the first question.
Well, I believe the answer is yes. Certain languages, if you just look at NLP generally, certain languages are better supported than others in the NLP community. So German, for example, is a language where the tools, the methods that have been worked on in English have also, there's parallels in German, French, Spanish. As you get further away in terms of volumes of people speaking the language, of course, then there's less coverage in the NLP community. Because a lot of what we're relying on are methods that were developed outside of our field that we're projecting into this field, you see? So we might call a method a general NLP method from a package, let's say, that was trained on either on English or a language that's spoken at a high enough volume to kind of for it to be supported, for there to be a community. So I've definitely seen this like with some languages that are not spoken nearly as commonly. Like I just remember having this conversation about Norwegian. Not that many people in the world speak the language, and there's just not as much support in the NLP community as there would be like for German or French or Spanish or something like that, where there's relatively speaking, quite a bit out there. So that's I guess what I would say. And yes, there are applications that have been built that work in various languages. English is clearly the most well supported though across the NLP tools, but it does start to tail off as you get away from. It's not a crazy thing you can imagine. Or the more spoken languages are better supported than the less spoken languages in the world.
Staying on the topic of NLP for a brief second, we've had questions around how do I get into the field? Are there books you would recommend? And then some people who have identified common problems when you work with language technology, like there are words that could mean very different things, though they are exactly the same representation of characters. And maybe you have a recommendation. I was just thinking that we should not underestimate the complexity of the field. I mean, this is a whole area of computer science, and people are tackling these problems, and they do so increasingly well. But what do I do when I'm just about to start? How do I get into that field? Or do you have any resources to cover that last part of it?
I think we'll send some stuff, some links out to some intro books if people want to get started. I think, there's the theory and applications. So on the theory side, there's work that's been done in NLP and then there's the application side is what programming language do I use to carry off or orchestrate these things? And those are kind of two tracks. So a classic thing would be R, which is a programming language, a statistical computing language, and then Python would be two possible languages. There's others you could, and then there's kind of the theory of NLP and the work that's been done. And again, as you noted, this is a very deep field. There are people who get whole PhDs in it. There are people that this is all they do all day is this. So there are entry points, but it's not it's something you have to work towards, just like anything. The whole idea that words can mean multiple things, that's the semantics problem. I mean, that's precisely what I was trying to identify. That's the semantics issue. What I would tell you in a longer form thing is I show you examples of, you'd be surprised how successful you would be just doing things like counting the frequency of words, even if you don't know what they mean. That's our bias, especially the lawyer bias, because we spend so much time on semantics as people that we think that that's the only way to interrogate a problem. And it's not. But again, it doesn't mean that every problem, there are problems where semantics is basically a requirement. I'll just put a person in front of it then. Forget the machine. I'll just use people. More generally, as I said in the pre-session, a lot of our field now is about how do I use people and machines and combine them to solve problems. So if I hit a part of the problem, the overall problem, that is go interpret the semantic meaning of this text, I'm not going to ask a machine for that. I'm going to have a person do that. And that's my view of it.
And so if we follow that thought and say we have now humans in the process, humans in the loop, as we say, isn't there a risk, and that's a whole other set of questions that go into this direction, that the application of these technologies actually lead to bad outcomes, reinforce bias that is in the data, reinforce bias that is in the system? Maybe
that's a very deep topic. Yeah, that's a topic in its own right. Yes, of course, that's true. I think it's a little bit of a harder. People sort of present that problem in a very particular way. They almost, when they ask the question, there's almost no interrogation of what's being done today. And I try to encourage everyone to talk about today's baseline performance. So classic example is, do I have a machine do this or do I have a person do it? So think about law. I could have a judge make a decision or I could have a machine make a decision. Now we know that this machine here is full of cognitive biases. They're very well documented. So it's a challenging thing. Okay, you think, well, okay, there's a lot of bias. in the existing system with the human-centered system. And then there's this machine system, which might learn from that and propagate those biases in the machines. Or we might be able to identify when you're trying to build that system, what those biases are that you're projecting into the other space. So I would encourage people to not be reflexively taking what people are doing today, at least it involves something like a criminal judgment or something like that. But in other applications, is this the change of control clause in the contract? Evaluate the performance and see which one's better. I think what happens is most of the times we've evaluated performance, it isn't nearly as good as it's advertised to be. But the question is almost always asked in this way where, hey, the process we do today is okay, or is basically okay, and now you're going to do the machines and it's going to become full of bias somehow. It's like, well, actually, when it's full of bias, why don't you look back at what's being done today? So anyway, there's a back and forth on that, a much longer conversation to have, but one that's being hashed out actively in the kind of AI community, at least right now. A lot of argument over that today.
So I think that you say the robo judges are probably rather a thing of the future. Though someone pointed out that we hear reports of it's somehow machine-based decision making, for example, in some Asian countries. Is that fake news, or is there more of a spectrum towards what we imagine when we think of a robo judge, and then automatic decisions that might already be happening today?
Well, sentencing guidelines are algorithms basically, or rules that judges have to follow. So if there's there's already this mixture of a machine and a people, in a sense that various jurisdictions at various points in time have created guidelines for what judges could give out, say, as a sentence in a context, or what is the amount of a tort liability there can be. So there's a layer of rules or an algorithm that already sits around it that constrains the set of choices the judge can make. So in every sense, that's an algorithm. It's just not a machine saying this is what you can do. It's sometimes I used to work for a judge. There's he would follow a laminated card so he didn't make a mistake. What is the sentence in this context? So he would. The point was it was so algorithmic that he would go to the part of the matrix and figure out where the situation was and make sure he didn't improperly assign, or he would know what his range was, for example. So we're already doing this in a sense all the time.
So then some people are worried
familiar than people think. It's not from a machine, it's from a piece of paper. It's a rule.
Gotcha. So as I said, some people are saying that there are good human parts in these processes, right? Is there a risk that we might lose what's good about it, like instinct or interpersonal attorney-client relationship? Is that something that where you would see a risk that goes away if we apply these methods and use these tools?
I'd still use people to sentence people to jail or something like that. I mean, I would, even knowing what I know about the justice system and what have you, I'd still do it. I don't think people are comfortable with it. There's other problems where, let's just submit our facts to a machine and leave it at that, especially in a commercial context, business to business commercial context, something like that. It's a different terrain. Again, that's a debate to be had, that's fine. That's a debate to be had, but I'm less comfortable in the context of the criminal law than I am in other places. But I want to focus you on it. The purpose for us presenting to you this was not necessarily, I want us to stay focused on, the point of this today is to show what are people doing today with these things, not kind of, the lawyer move is always like, well, should we regulate it or, rather like just understand what it actually is first and what is being done. And that's what we're trying to at least give you the preview of. Because I get, people are automatically concerned without fully knowing what it is and what the, pluses and minuses of it are. That was at least my context today, was to try to show you, here's all these application areas. And for everyone I showed you, there's many others where people are using this technology in one form or another. But I have my own views. You're free to take, to have whatever you'd like as you can take your own position.
So then I say I have maybe 2 or 3 more groups of questions.
Fine. People can drop off if they need to, but we'll go until we at least exhaust a few more of them.
So one is, there are some areas where we see a lot of applications on the market It looks like surfacing information for due diligences, for example. And someone wanted to know, so what about other areas like contract negotiations? Is there a reason that some parts of the market are ahead of others? Why do you think that is? And then connected to that is, of course, the $1 million question. What do you think is the next big problem in law that AI will solve or may become very good at least solving?
Okay. Well, I think at the end of the day, and we did this in the pre-session, but I'll say it again, I think it's a question of engineering possibility and economics. What is technically possible to be done with a machine? And the economics part is, where does it make sense to do it economically? So it is not a huge mistake or accident that the first major incursion of these principles was in e-discovery, because we're just sitting there with mountains of emails to this. The problem was created by technology. Our desire to just craft an email every 5 seconds. Sorry for the ones we've sent you, by the way, but then you wouldn't have the link. But the volume of emails that we have just in normal kind of existence has created the need to use machines to solve a problem that machines created, essentially. And so it's not a surprise that that's the first place we saw a major incursion. Look at the places where there's large volumes of people doing work all day, looking at documents and trying to pull pieces of information out of those documents. So it's not a surprise that e-discovery was the first wave and diligence was the second wave, and then things have fanned out from there a bit. But I think that's just again, what is, from an engineering perspective, what is possible, and in an economic perspective, where does it make sense? And that's why we've seen lots of companies around those topics, because they meet both of those gating criteria. What do I think is the next frontier? Machine summarization, I think, is a place that you see very little work that's been done on the commercial side, at least, in machine summarization. So machines are getting better and better at taking large bodies of documents and giving you a summarization of those documents. Now, nobody believes the summarization you got from that would be perfect or airtight or anything like that. But think about this. If you could get a rough summary of a very large body of documents that your team may not be able to provide you a view of for weeks, and you could have it today, and it wouldn't be perfect, but you'd have a glimpse into it. That is something that's useful to people, at least in my view. And that's useful in doing deals, and that's useful in litigation and a variety of other areas, by the way. So I think kind of that's a frontier where I've seen relatively little done, and I would expect to see more in this decade, because there are a number of problems where being able to get essentially a preview or an early glimpse can be very useful to you.
And then I have a number of questions naturally arising and very interesting to us both as educators. So what are the kinds of skills that lawyers today and lawyers of the future, law students of today, might need? And how do I get started? How do I do it? There was a question saying, look, if I feel like a freshman to all these topics, what do I do? How do I familiarize myself with it? Because the field and the educational opportunities look very fragmented right now. How would you solve that? Or what do you tell someone who wants to make sure that he or she has the right skills for the future, or the future in which technology plays a key role?
Well, I mean, this is a start here today, and now we'll go from there. So for everything I've done there, you can go deeper and deeper into all of these. There's a lot of, so for my students at my school, we have 15-week courses in a bunch of these topics, and Bucerius will have, at least in some of these, has some already, and we'll have more in the probably in the years to come. If your school does not, there are online courses that are places where you can kind of self-teach or get yourself certification. It's going to be a harder path, obviously, if your home institution isn't a place that necessarily has all this. Universities are not always perfect at adapting to the changing landscape for a range of reasons. But I mean, you have to look at it and make a decision for yourself and what you see out there. If you think what we're saying is even half right, then I think you probably need to dedicate some time to build your skills. And this is a step. What we're doing here with this online offering, we hope to do more things along these lines in the months and years to come. But again, there are platforms out there where you can learn the substantive tools and like things like programming. And that's a whole debate. Should lawyers learn to program? I think, well, I think you're in the whatever it has to be situation. In other words, whatever one has to do, you do. And if it involves programming, then so be it. If it involves knowing more about programming or how at least you could work with a dev team successfully, that would be at least a step in the right direction relative to your peers.
So that's
a deep subject. We know that's a session.
There were questions. There were like a lot of questions on what do I need? Do you think that people need to learn programming in order to properly work for the future? And that ties to another question that we've had is, so there will be regulation for all of this, right? We're talking a lot about legal technology, but there's of course technology law. And to what extent do people need technical skills to perform that is one question. And then the second one, which I believe is reflective of I think there's a subtone of the person asking it that say, wouldn't it be important to first understand and regulate these technologies and not jump to making money and using them and applying them and then fix things afterwards? So shouldn't we work a lot slower and figure all of this out, make laws, and then maybe see the benefits of this? Are we acting too fast, is I guess what this person says.
Well, let's just talk about the programming topic. I think it would behoove people who want to do this. Now, this isn't for everyone. Okay, so if you look, most of the lawyers practicing most of the world don't really know a tremendous amount about most of this. Okay, but my view has always been, if you're a junior lawyer in particular, this is something where a senior person could actually look to you and say, what do you think? You seem to know more about this than I do. That's never going to happen on the substance, probably, at least not initially. They're not going to say, wait a minute, I've been doing this a long time and you just started. Let me get your position on all this. I mean, it could happen, but you know what I'm trying to say. This is a place where you could basically have a chance to maybe be at the front of the line relative to other topics where that's very unlikely to happen anytime soon. So I view it as a place where you might be able to get a niche or a comparative advantage over people who have a lot more experience and substantive knowledge than you do at this point in time. So especially for the law students and junior lawyers, part of the idea for this has always been it's a way to differentiate yourself out there, especially at the beginning. In terms of the regulatory side, of course, these because I mean, it was one of the two things I said at the beginning. Your client's world is becoming these topics in various forms. So knowing more about what we're actually talking about is a useful thing, it seems to me. There is an impulse to regulate first and then, figure out the harms later, figure out, what we can allow later. I mean, obviously not every country has the same view on all those topics. But then somebody's going to say, well, wait, can I do this under these rules? And, if you know enough about the technology and the underlying rule set, then you're in a position to provide advice and help guide that person. So again, I view this as kind of positive in a lot of different dimensions. But again, this is a long form thing. One could say a lot about that.
So from what you said, I take that you're making the point for skill stacking, basically. Because we have had a couple of questions where someone said, why should someone who is a world-class lawyer already now try to become a data scientist as well? Wouldn't it be?
I don't think if you're a world-class lawyer already, then you could work in an organization where you should try to get somebody around you who has the skills and work in a complementary manner with that person. There's no reason that you have to play every instrument, but you ought to know what's possible. You ought to know what's possible so that, if you're the world's best expert in whatever the topic is, then the question is, well, first people say, you can't do what I do with a machine. That's kind of step one. Then you'll say, okay. Maybe you can kind of get them off that. And then, I often say to them, what would you do if you knew the following was possible? How would that allow you to do more or do something better than you can do it today? And that's a less kind of you're being replaced by a machine than what is being made possible. Now, obviously, I don't think that that's a completely neutral concept in the labor market broadly, but to that person who has all that information expertise, there are ways in which they can accelerate their skills essentially by either doing that, having this knowledge, or at least being on a team where those people do have that knowledge set. That's what I would say to them. Just don't take it in that way where it's like, am I being replaced or not by a robot? It's more like, what is being facilitated or made possible? That you just said, well, we can't do that. That's not possible. And then it turns out it is.
So the final group of questions I have, I think, is united by asking for more in-depth information and questions related to topics that we have later on in the program. So I think I'll take a moment to highlight that. Many people asked, what does this mean for courts? What does this mean for justice?
We got a lot on that to come, right? So stay tuned.
And by the way, there it wouldn't be, I think, at least from my perspective, it wouldn't be fair to have one person answering all the questions, because we need people who are the real experts in that, who have experience in the court system, who have been talking to the people who make the regulations. I think that's also an important point. You want to hear from the experts on these area, and that is true also for the whole area of legal operations. So we've had questions involving how do I manage a client intake? What are the risks? Are there firms already doing this successfully? Do they pre-screen cases they take? How do legal departments handle that? And I also think that in that aspect, we do have some great people coming in the next few weeks to do that. So I think this is all what we have time for today. Again, the conversation continues on Twitter. Thank you, Dan, for spending the time with us and for working with me in Bucerius Law School to get this thing further along.
Yes, I'll see everyone. Dirk and I will be hosting over the days to come, so I'll see more of you, all of you, in the over the course of our sessions. Thank you very much, and signing off here from Chicago. Have a great day, everyone. Take care.
And goodbye from Hamburg. See you tomorrow.